Hello everyone. Now we are going to see about CMOS amplifiers. So first one is common source stage. So in the CMOS amplifiers, first we are going to see about common source stage. So in this MOSFET, this is N-type MOSFET. Here we are having three terminals: gate, drain, and then source. So common source stage means source is common for input and output. At the gate terminal we are giving input, at the drain terminal we are taking the output, and source is common, so this is grounded here. So this is called common source amplifier. Here M1 converts the input voltage variations to proportional drain current, and RD transforms the drain currents to the output voltage Vout. So this is the diagram for common source voltage. This is what the corresponding small signal model of this common source stage. So here we are having input voltage Vin, and at this between gate and source we are measuring the V1 input voltage, and this is my source, this is my gate terminal, this is my source. So source is grounded here, this is my drain terminal. So here in the drain terminal we are measuring the output current ID. So what is that ID is GMV1. GM is nothing but transconductance. So transconductance into voltage that will give the drain current, and output side we are having RD, so that is mentioned here. So here we are taking the Vout. This is what the small signal model of common source stage. So here in this by using the small signal model we are going to find what is the voltage gain, input impedance and output impedance. So here now we are going to find what is voltage gain. So to find voltage gain we should have output voltage and input voltage. So what is Vin here? Vin is equal to V1. What is Vout? Vout equal to this ID, current into resistance. That is what V equal to I into R. So ID is nothing but here minus, so this is 180 degree out of it, so minus GMV1 into RD. This is what my Vout. Now I am having Vin and Vout. Using these two we can measure what is our voltage gain AV. So AV equal to output voltage by input voltage. This is what voltage gain. So that is equal to Vout equal to minus GM V1 RD, substitute here, and Vin is equal to V1. So substitute that value here. V1 both will be cancelled. So remaining I am having minus GM RD. This is what the voltage gain. Where GM we are having one equation for GM, that is a transconductance equation, that is equal to root of 2 mu n Cox W by L into ID. This is what the transconductance equation. Substitute this value I'm just representing this as equation number 2. This is AV equal to minus GMRD. This is equation number 1. So substitute 2 in 1, we will get AV equal to minus root of 2 mu n Cox W by L ID into this RD. This is my voltage gain. For M1, here we are considering M1 is in saturation region. So to make this M1 in saturation region, what is the condition is VDD, that is VDD minus ID RD. This voltage difference should be greater than VGS minus VTH. The gate voltage between gate and source minus VTH. So VDD minus ID RD, that should be greater than VGS minus VTH. From this we are finding ID RD. So ID RD, that is lesser than VDD minus VGS minus VTH. This is what the condition. So next we are going to find what is the input impedance, what is the output impedance. So input resistance and output resistance. Here the gate terminal current is 0. So In equal to 0. Then how to find Rin? Rin equal to Vin by In. In is 0 because gate current is 0. So In will become 0. So if you are substituting that, your input resistance will become infinitive. Then output resistance, so Rout that is equal to RD. Output resistance is equal to drain resistance RD. So this diagram shows the output impedance of common source stage. Here to find output resistance we are making gate voltage is 0, and we are passing some test voltage at the output side, so Vx, and from this we can measure what is Ix. This is the diagram for output impedance of common source stage. So these two equations represents input resistance or input impedance and output impedance or output resistance. Next I am having till this we have considered the channel length modulation is 0. There is no channel length modulation, but practically we cannot neglect the channel length modulation. So if you are considering that your this small signal model diagram, this will become like this. Here we have to add, if you are considering channel length modulation, you have to consider one extra output resistance that is added with your output. So what will be your equation, that is gain equation, is AV equal to minus GM RD parallel RO. RD parallel RO. See here, this resistance will be added because of this channel length modulation. Then your input resistance, that there is no change, that will becomes infinitive. And next, output resistance, if you are not considering channel length modulation, your output resistance will be equal to RD. If you are considering channel length modulation, then that will be equal to RD parallel RO. This is what about output resistance. So common source stage and with small signal model, and what is the if you are neglecting channel length modulation, what is the gain, input resistance and output resistance. If you are considering the channel length modulation, what is the gain, and then what is the input resistance, what is the output resistance. This is what we have discussed now. Thank you for watching.